before. There might be some new stuff going on, so hopefully it's not too like earth-shattering or anything. So an inequality is an algebraic expression containing less than or greater than signs, an inequality in it. We'll see. Less than or. Y'all, you gotta grab notes whenever you come in. If there's anything on the front counter, you grab it. This is the third week of school now. It should not be something that we don't do. So what does this sign mean? Anybody know?
Less than, greater than.
Which one is that? Less than.
Oh, it is?
Yep. Because like if it was written out, if we had like x is less than 6, right? That's saying this number is smaller than that one. So it's a less than, yeah? Okay. So what about the other one? What does that one say? Greater than. So here in a second, we're gonna graph these. Have y'all ever graphed inequalities before? Yeah? Okay, so when you've got these signs, you graph it with an open circle. What do these signs mean?
Closed circle.
Closed circle, okay. And like, how would we say it verbally? What's the difference?
Less than or equal to.
Good. So then the other one instead of less than is what?
Greater than.
There you go. And like I said earlier, you'll use a closed circle for those. There's one special thing that you have to remember when you're solving inequalities. So anytime you divide or multiply, by a negative number, you've got to flip your inequality sign. So I would like circle, highlight, underline. Make sure when you divide or multiply by a negative that you flip your inequality. Have we solved inequalities before? Yes, so maybe. Well, we'll do that in a minute, so if you haven't, hopefully it'll refresh your memory. So if we wanted to graph x is greater than, how do we do that? Well, we gotta decide, do you have an open circle or a closed circle? Open circle, so you would go to 2 and draw an open circle. And then do y'all remember how you like shade it one direction or the other? Yeah. How do we decide which way to shade? It's the way that it's pointing. Has anybody ever told y'all that trick before? As long as your x is on the left-hand side, if it's pointing that direction, that's the direction we'll shade. That makes sense? So we'll make our arrow go this way. So you could like test that just to be sure you're correct. We know that this says x is bigger than 2, right? X is greater than 2. Do you agree? So pick a number bigger than 2. Do we have 3 colored or covered in that direction? Yeah. So that means that we colored it the right way. Does that make any sense? Do you get what I'm saying? Okay. So let's do the next one. So this time we've got x is less than or equal to 6. So we're going to have an open circle or closed circle? Closed circle. So we've got a 6. Close your circle in. And this time, which direction are we pointing? Left or right? Left. So we'll shade that direction. And we could test it. What's something smaller than 6? -2? Or did we say -10? Did we color over -2 or -10? Yes. Yes, so we shaded in the right direction. Does that make sense? Questions? Okay. So for the next part, we've got to solve them before we can graph them. So do you think there's anything different about solving inequalities than solving like regular equations? There's only one special thing you have to remember. What is it? flip it, we divide or multiply by a what? Negative. Exactly. So everything else is exactly the same. So what do you think we need to do first to solve this one? Add 7. Good. So we'll have 4x is greater than 7 plus 17. What do we get? Then what do we do next? So x is greater than what? So once we solved, we can graph our answer. So we're going to have an open circle or closed circle? Open circle, so go to 6, open circle, and do we shade left or right? Left or right? So when we graph that answer, do we know what that means? Do we know what we're like representing? It's okay if you don't, I'm just curious if we know. Because I feel like a lot of times in math we just do stuff because like our teacher told us to, but we don't really know why we're doing it. So do we know why we're doing this? So this is showing you all the possible values of x that would make this inequality true. Okay, so when you do that, you're saying everything this direction of 6 we could plug in here and it would still make a true statement. Does that make any sense? So that's what you're showing, okay? Questions on that? Are you ready to try another one? Okie dokie, so look at number 2. What do we think we need to do first there?
Minus 10.
Good. Minus 10. So we'll have negative 8x is greater than 26 minus 10 gives us what?
16.
Okay. What's our next step? So we're dividing by negative 8. Ding, ding, ding. What do we need to do here? So instead of x is greater than, we'll say x is less than. 16 divided by negative 8 gives you what? Negative 2. So when we go graph that, we're going to have open circle or closed circle? Open circle at negative 2. And our x is still on the left-hand side, so we're good to shade the direction it's pointing. So do we shade left or right? Left. So that's just, again, showing us that all the numbers that are smaller than negative 2, we could plug in for x and it would still be a true statement. So I think they'll call that like your solution set sometimes. So you may have an inequality and they'll say which of the following values is not part of your solution set. So then you look for stuff that falls out of like what you shaded or whatever. And that will get a little bit more involved later on. So looking at number 3, what do we need to do first there?
Subtract 34.
Good. Yep, subtract 34. So 14 minus 34, what do we get?
Negative 20.
Good. Less than or equal to 5x. And what's our last step?
Divide by 5.
Divide by 5. So negative 20 divided by 5, what do we get? Now, do we have to flip our inequality sign here?
Yep.
So I think this is tricky. You don't have to, because the number on the bottom of our fraction wasn't negative. Okay, so if the number you're dividing by, the one you put on the bottom, if that's negative, then you've got to flip it. Ours was positive, so we don't have to worry about that. But what else is wrong with this?
The x is on the right side.
The x is on the right-hand side, which is fine, but we just don't like it that way. So can we rewrite it so that it's the way that we like it? So I'm going to switch the x and the negative 4. Now, which one was it open to down here, the x or the negative 4?
The x.
X, so we need to keep it that way. Does that make any sense? Any questions there? All right, so we want to go and graph this now. So at negative 4, we can have an open circle or a closed circle?
Close.
Closed circle, so negative 4, closed circle. And do we shade left or right? To the right. All right, moving on. So number 4, what do we have to do first there? Distribute. So negative 4 times 2x, what do we get? Negative 4 times negative 6, what do we get? Oh, this is less than x plus 6. So we have x's on each side. We want to get them all on the same side. So we could add 8x or minus 1x. What do y'all want to do? So we can add 8x. I'm only going to suggest the other one because which side do we want our x's on at the end?
Left side.
The left side. So it might be easier in this case just to minus 1x over because you'll have to do less later. So what do y'all want to do? Is it okay if we do that? All right. If you want to do it the other way, that's totally fine. You should still come out with the same answer as us. So if you want to keep doing that, you can. So that'll give us with negative 9x plus 24 less than 6. So what do we do from there? Minus 24. And our last step, divide by negative 9. When you divide by a negative, what do you have to do? Flip it, so we've now got x is greater than 2. And if you solved it the other way, you probably just had 2 is less than x, but it's the same thing. So when we go graph this, do we have an open circle or a closed circle? Open circle at positive 2. Do we shade left or right? Questions? All right. So number 5. Do you want to try that one on your own? Yeah, no, maybe? No. What's our first step? Distribute. So 2 times 7x, what do you get? 2 times negative 1. Greater than or equal to, then distribute again. What's 3 times 5? And 3 times negative x. So again, you've got x's on both sides. We said that we have to get them together, and we want our x on the left-hand side. So I think it's easier to add 3x, but you could also subtract 14x. Either way would be fine. What do y'all want to do?
Add 3x.
Good choice. Then what do we do from there? Add 2. And our last step, so when we go graph that, are we going to have an open circle or a closed circle? Closed circle at 1, do we shade left or right? To the right. Questions? So the back side is talking about compound inequalities, which just means more than one happening at the same time. So we've got 2 different kinds. You've got and statements and you've got or statements. So and statements are like an intersection. So you're thinking, what do they have in common? And or statements is like if it's true for one of them, then it could be part of the solution. So or is kind of more inclusive. So if it works for this one or this one, it'll be part of our solution set. An and statement, it'll only be where the 2 parts have in common. So I'll show you what that means right here. So we'll graph these 2 individually. If you're not using a pencil, I recommend that you use a pencil for this because we're going to have to erase some things. So I'm going to switch out to a pencil for a second. So we're going to graph x is less than 4. So are we going to have an open circle or closed circle? Open circle. So at 4, we'll have an open circle. Do we shade left or right? To the left. So then we're going to graph x is greater than or equal to 2. So at 2, are we going to have an open circle or closed circle? Closed circle. Do we shade left or right? To the right. What do you notice has happened? They're intersecting each other, right? And because it says and in between those two, we only want the part of the graph where they intersect. So we can erase everything up to that point. So our solution set is only going to be from 2 to 4 because we only want the part where they intersect, what they have in common. Does that make any sense? So we're going to go get rid of all the stuff on the ends that's not part of our answer. Questions there? So again, that's how you treat and statements. So and is whatever they have in common, or like an intersection. So and is an intersection. What do they have in common? So if it's an or statement, that's a union. So you're just joining whatever works for either statement that you have. We'll graph x is less than 2. So at 2, are we gonna have an open circle or closed circle? Open circle. And do we shade left or right? To the left. Okay, then we're going to graph x is greater than or equal to 4. So at 4, do we have an open circle or closed circle? Closed circle. And do we shade left or right? To the right. So is there any word where these two overlap? No, and that's okay because this is an or statement. So you're going to keep whatever works for either statement. So basically, what's the only thing that won't work for this? 3. The only part of your graph that's not colored, right? So that would be like at 3 or those decimals leading up to 3 and 4. Does that make any sense? Yes, no, maybe? Do you have questions? So if we're talking about this one, could 9 be part of our solution set? Yeah, what about negative 9? What about 2.5? What do you think about 2.5? I can't hear what you're saying because we're just mumbling. Somebody said no. Why?
No, because I don't know why.
Because like they don't intersect. There's like no. They don't
Is it colored at 2.5? No, we stop at going up to 2, right? So anything past that before you get to 4 won't work. Questions on any of that? I feel like it's not super complicated, but I also don't want to just like breeze past it. So if we're good, we'll go ahead and do a couple of these together on the back. So I want to do which ones? I want to do 2 and 3 together, and then I'll let you try the rest on your own, because it's basically just the same thing. So we'll do number 2 first. So this one's an or statement. So we know that whatever is true for either one will be part of our solution set. So we're going to have to solve each of these individually. So looking at the first part, what do we need to do to solve that inequality?
subtract.
-9. Then what?
Dollar 3.
So then we have to solve our other inequality as well. Let's see. I'm tired of hearing the same people talk all the time. So let's see. MJ, what do we do next? Or what do we do to solve this one? -1. So we'll have negative 2x is less than negative 6. Mackenzie, what do we do from there? What are we trying to get rid of in front of the x?
The negative.
Negative what? What number's in front of x?
2.
Yes. Sorry.
How can you not see it?
You divide negative 2.
It's not how I can see it.
Divide by negative 2. Yeah, that's right. I goofed on this side. I put negative 6. I thought it was negative 5. It's not. So that should be 4 over there. Then when we divide by a negative, what happens?
Can't.
With your inequality sign, what happens?
It flips.
It flips. So we've got a greater than. And then 4 divided by negative 2 gives us another negative 2. Are we okay with that? All right, so we need to graph these two things. So Ashton, when we graph x is less than negative 4, is that going to be an open circle or a closed circle? Open circle, so at negative 4, we got an open circle. And do we shade left or right? Good. So then we also have to graph x is greater than negative 2. So pay in. Are we going to have an open circle or a closed circle at negative 2? Open circle at negative 2. Open circle. And do we shade left or right?
Right.
Yes, ma'am. Shade to the right. So since this is an or statement, we'll just leave our graph just like that because anything that's true for either one will be part of our solution set. Questions there? I'm going to highlight where it says or so that we know why we did it that way. All right, so looking at number 3, are we ready to try one that's just a little bit harder? I don't want to like blow your mind, but I don't think it's bad yet. Do we need to do a regular and statement first? Yeah, okay. So we'll do number 1. So this one's just an and statement. So anytime it's an and statement, our answer is going to be where they intersect, right? So whatever they end up having in common. So definitely make sure that we use pencil on this one. So we need to solve this inequality first. So what is going on there?
2x minus 4 is less than or equal to 3x.
Yeah, so what's the problem? I think somebody said it.
There's 2x.
X is on both sides, right? So I looked at that and immediately wanted to add 1. Is that what we should do here?
No.
Why not?
Because you gotta get them on the different sides, and if you add 1,
It's not really helping anything, right? We want our x's together. So would it be better to minus 2x or minus 3x? Minus 2x. Even though that's going to put our x on the side that we don't like it on, we can fix that later. So I'll have negative 1 is less than or equal to 3x minus 2x gives you what? Or just x, right? So that's basically solved, right? Now we just said that we don't like the x being on this side. So to fix that, we can just switch the x to the negative 1. Then make sure that our inequality sign stays open to the x. So we'll have x is greater than or equal to negative 1. Is that okay? Questions? All right, so then looking at our next inequality, we've got x is greater than 4x minus 9. So again, we have x's on both sides. So what do we need to do first? We're going to subtract our x's, get them on the same side, right? So would it be helpful to add 9? No, right? Because that's just going to move it to the other side. I would minus 4x. Yeah? Is that what y'all would do? So x minus 4x, what do we get? Good. The negative 3x is greater than negative 9. Jaden, what do we do from there? There you go. Divide by negative 3. Anytime we divide by a negative, what do you have to do with your inequality? Flip it. So instead of x is greater, we'll say x is less than. Negative 9 divided by negative 3 gives us what, y'all? 3. So we'll graph these two inequalities. Then since it's an and statement, we'll have to look and see where they intersect. So we'll start with the first one. So x is greater than or equal to negative 1. So Matt, is that going to be an open circle or a closed circle at negative 1? Closed circle, and do we shade left or right? To the right, good. So, buddy, for x is less than 3, is that going to be an open circle or a closed circle? Open circle, and do we shade left or right? Yeah, shade to the left. Now, again, we said this is an and statement, so we look to see where the graphs do what? Intersect. And where does that happen? In the middle, right? So we can erase everything on the ends. Y'all, 90% of the time, if you've got an and statement, it's going to be whatever is between the two numbers that you get. Any questions so far? We still all right? Okay, so looking at the next one. How adventurous are we feeling? Because there's two different ways to solve these. And I think that y'all could handle learning both. Are we okay with that? We'll do the easy way first. Do y'all think it's easier to have two equations or one? Or two inequalities or one? I think one's a little bit easier, right? So I'm going to show you that way first. Okay. So if we're looking here, we've got 3 is less than 2m minus 1 is less than 9. So what do we think we might need to do first to start getting m by itself? Okay. Add 1, right? Does that make sense? So if we add 1 here, where do you think we also need to add 1? Somebody said it. To the 3. Anywhere else?
In the 9.
To the 9, right? Because you got to do it to both sides, or well, all 3 sides, I guess. So this one would cancel out, and then 3 plus 1 is going to give us 4 is less than 2m is less than 10. Are we okay? So again, we're trying to get m by itself. So what do you think we might need to do?
Subtract.
Divide by 2. What do we need to divide by 2? Everything. So 4 needs to be divided by 2, 2m is divided by 2, and 10 is divided by 2. So what is 4 divided by 2? And then 10 divided by 2 gives us 5. Is that okay? Did that blow anybody's mind? So do you want me to show you another way to do this so it might be a little bit easier? Yeah? Okay. So we'll go back to our original equation. So we've got 3 is less than 2m minus 1 less than 9. All right, so we want to solve this, but it's like 2 inequalities, right? So what we can do is take the first chunk and write it as an inequality. Then take the second chunk and write it as a second inequality. Does that make any sense? So you're basically just taking the middle. You're writing this as an inequality and writing this as an inequality. And we'll solve it as 2 separate ones. Instead of doing it all together, you just do 2 separate. So again, we'll add 1, right? Add 1. Is that okay? That's so good. And then divide by 2. So we'll have 2 is less than m. And then over here, we'll add 1. Then divide by 2. So we ended up with the same thing, right? We have 2 is less than m and m is less than 5, which is what we have over here. It's just written a little bit differently. Does that make sense? Yes, no, maybe? So I don't care which way you do it. Whichever one makes more sense to you is fine with me. So the important thing to remember with this is that it's an and statement. So anytime you're dealing with an and statement, you're looking to see where your graphs do what?
Intersect.
Where they intersect, right? So if you split it up into two inequalities, I think it's pretty easy to graph these separately. Do you remember what I said is probably going to happen 90% of the time with an and statement? It's going to be in between whichever two numbers you have. So if you look at our answer down here, M is between what two numbers? 2 and 5. So we're probably going to end up shading between 2 and 5. So I'm going to look at these two inequalities and we'll go from here first. So if we switch this one so that it points the direction we want it to. At 2, are we going to have an open circle or closed circle? Open circle at 2. And we'll shade it to the right. And then at 5, do we have an open circle or a closed circle? Open circle.
You're a little early, but
And do we shade left or right? Left or right? Where do you sit? That's a good question. You are beside Macy.
right here in the middle.
Macy, can you raise your hand? Guess it's beside her. Thank you.
Is it the side or behind?
Beside her. So once we graph those two, it's an and statement. So again, where are we looking? In between, so, or where they intersect, so it's going to be between 2 and 5. So I'm going to erase the ends. When y'all start doing homework in a second, you'll have some that look just like this. So anytime y'all have that, you'll just color in between those two numbers. It'll work like that every single time. So let's pretend that you have something else, because I feel like y'all are still not quite understanding what I'm saying. We've got -1 is less than x is less than 5. Or we'll go 4. How would you graph that? First off, open circles or closed circles? Open circles at what? -1 and 4. And then where do you shade?
One's left. So it's x. So you shade the grade of one to the right, and then negative, and then inequality 4 to the left.
This is an and statement, so we want where they intersect. Where's that going to happen?
2, 3, yeah, 2 and 3.
Everything in between, yeah? So let's try another one because we're still not quite getting. So if we've got 2 is less than x is less than 7, it will make them equal to this time. All right, what's going to be different? Open circles or closed circles? Closed circles? Closed circles. And where do we shade? Where have we ended up shading every single time? In between. Y'all, that's all I need you to get from this. If you have something that looks like that, shade in between those numbers. That's all. Yes? No? Maybe? Questions? Okay. So I want you to try 4 and 5 on your own. Can we do that? 4 and 5 on your own. Yeah? Okay. So try those two, then we'll go over them in a minute or 2. Or 5. Alright, so looking at number 4, we've got an and statement this time. So anytime you have an and statement, your answer is going to be where the answers do what? In between, or where they intersect or overlap, okay? So looking at our first inequality, we need to solve that. So let's see, Macy, what should we do? Minus what? For the first one right here? Michaela, what do you think?
Subtract.
Yeah, we're going to minus 2 because we want to solve for b. So you're trying to get stuff away from that. So you're left with -6b is greater than 6. Macy, what do you think now? What do you think we should do now? divide by what? Negative 6. So when you divide by a negative, what happens with your inequality, y'all? Flip it. So b is less than negative 1. That okay? Questions? Alright, so looking at the next part, we've got 8b minus 5 is greater than negative 85. So Trent, what do we do first?
Plus 5 or
Yep.
plus 85.
We'll add 5. Why would we not add 85 this time, y'all?
So again,
It's on the other side. We want to get stuff away from B. So if you're adding more stuff over to the same side that B is on, it's not really going to be helpful. So negative 85 plus 5, what do we get? What? Braden. It doesn't have a last name, so any Braden, I guess.
Oh, that's probably me.
Probs. Okay. So, what do we do from there?
Hey, say divide by 8.
Is that okay? Just so maybe. Alright, so we need to graph these. Look at the first one. We got B is less than negative 1. So Savannah, are we going to have an open circle or a closed circle? Open circle at negative 1. Do we shade left or right? Yes, ma'am. Or we'll shade to the left. Oh, I should have done this in pen. Then for the second part, we got B is greater than negative 10. So Zach, is that going to be an open circle or closed circle? Open circle at negative 10. And do we shade to the left or the right? To the right? So where's our answer going to be? Because it's an and statement. Sierra, where's their answer going to be?
What?
We've got the two graphs. Where's our answer?
Oh, in between.
In between. So erase the ones on the end. I goofed and did it in pencil or in pen, so I can't erase this end. But this stuff. That okay? Questions there? What part of that told us it would have to be in between? And. So anytime you see an and statement, where is it probably going to be? In between. Now I do have a question for you. What if it was an and statement, but your graph, we're going in like opposite directions? Let's pretend that it looks something like this. If it's an and statement, where you look to see where the graphs do what? Where they intersect. Do they ever intersect? So, what would we say? It's kind of like a false statement, and what do we say? If we get a false statement, what do we say? No solution. Exactly. Yeah. Good job. All right, so moving on to number 5. This one's an or statement. So we're looking to see where either one is true. So we've got negative 6k minus 1 is less than 53. Crystal, what do we need to do first? Yeah, add 1. Good. So we'll add 1. So we've got negative 6k is less than 54. Evan, what do we do from there? Divide by negative 6. So k, and then what do you do with your inequality sign? Flip it. 54 divided by negative 6 gives us what? Positive or negative?
Oh,
Yes. That okay? Alright, so then we've got 10k plus 1 is less than or equal to 81. So Michaela, what do we do first?
we subtract 1.
Good. Minus 1s, we'll have 10k is less than or equal to 80. Braden Williams, what do we do from there? Do you know why we're dividing by 10? So we're trying to get k by itself. And what operation is happening if they're touching like that? What does 10K mean? Right, so it's multiplying. So to undo that, we're dividing. Yeah? So K is less than or equal to 8. That okay? Questions? All right, so now we need to graph these. So Connor, if we're doing K is greater than -9, so that can be an open circle or closed circle. Open circle at -9, do we shade left or right?
Right. No, right.
To the right, good. All right, then we've got to graph K is less than or equal to 8. So Samuel, help me out. Is that going to be open circle or closed circle? Closed circle, and do we shade left or right? To the left. Y'all, what's happened? They're like taking up the whole graph. So if everything is colored by something at some point, what do you think our answer might be? How do we say everything in an intelligent, mathy way? All real numbers. Mm-hmm. Do we have questions on any of that?